Okay, so pretty much what we're trying to say is this. See how NaOH, for every one of NaOH, you're gonna have the same OH, right? Because we just show you how you break it apart. So that's gonna be the same. How about KOH?
Same.
It's the same. So we're gonna say 0.0050 molarity. Okay, now let's go with CaOH2.
No. Oh, this is 208.
Right, so for every one of this, it's gonna break into
208.
two of this. So therefore the answer is
Um,
0.01, right? Meaning I'm gonna need to multiply by 2 for this. Right? Okay. Right, because for every one of CaOH2, I'm gonna break into 2 of the OH minus, right? Make sense? Yeah? 0.005 times 2. Okay. Alright, POH. Not pH. OH minus to POH minus, how do you do it? Negative log of OH minus, right? Make sense? Okay, now is what you're trying to do. If I have POH and I want pH, how would you do it? 14 minus POH. Make sense with that equation? All right, go ahead and do your calculator. I'm going to try them too. I'm only doing the last one, just so you know. Wait, actually, the last one don't need a calculator. Because I don't want to do it. That would be a 2. Yeah. Negative log time 0.01. Yeah. Try typing it. The last one give you 2, right? Suffix? Decimal. So you can see here how many suffix these has. How many suffix here? 2, right? So suffix in a pH and POH is a decimal. So I need to write 2 decimal here. Like that. Okay? So that means for the first one, I'm going to round it to what? 0.60, right? And then 14 minus, right, 0.60, so that would be 13.40. You can see that it is a basic. It has a pH greater than 7. Right? Okay? Oh, what happened? We got it? Okay, what is a POH here? 2.30, right? And then you're going to say minus 14. So we're going to get 11.70. Okay? 2 suffix, so 2 decimal. Okay? That is 2 decimal here, meaning there is 2 suffix here. Okay? Oh, let me pull it up. Okay. Make sense? All right, let's go to the next one. Okay. You gotta fill in that box, missing information. Hey, actually, you should know how to do it. Yeah. Right? Okay. Actually, how about I'll give you 5 minutes for you to fill D and then answer down the question for acid base down here. Let's see how much you remember. Okay. If I were you, I would try to answer these without looking at the answer key first. And then answer key is in your note first, if you remember. And then you can look at your note for, because these two are the review, right? You're summarizing your section. Okay? Got it? All right, let me see. Let me pause that one for a second. Okay, guys, pay attention to this. I know there are 2 questions that people are having. How do you get to the OH minus concentration? POH is equal to negative log of OH minus. So if I want to find OH minus, you do 10 to the negative of POH. You're going to get these. Now notice that I'm missing something. What am I missing? molarity. These are concentration. I do need a unit. Okay. Also, notice my decimal here for the POH match my suffix for my concentration. Okay. Now, I'm going to tell you guys that in this case, concentration of NaOH is equal to concentration of OH minus because each NaOH is going to break into one of the OH. Right? One OH. Now, this side, I wrote it like this because, take a look at this. You have SrOH2. If it breaks up, what you're going to have? You're going to have Sr plus 2, and then you're going to have 2 of the OH minus. You guys are multiplying by 2 because you see this 2. But guess the answer that you guys get. When you do this equation, you are getting OH minus. This guy. That means if I have X amount of this, how much would I have here? 2X. This is 2X that you guys are getting. So if I want to find X, what would you do? There you go. That's why I divide this side by 2 to get this. I don't know if you noticed they have the same POH. Yeah? Okay. Now, the next part, the bottom part. Okay. Tell me all the strong acids. Well, you should know all the strong acids, right? HCl, Br, I, HClO3, HClO4, H2SO4, and HNO3. Okay. What is the difference between strong acid and a weak acid?
Strong acids will fully dissociate into ions when dissolved. Weak acids do not.
Right. That's all we're going to talk about. Strong acid, fully dissociate. We're going to break apart. It's just one arrow. Weak acids, 2 arrow. Right? Strongly dissociate. Strong acid, dissociate completely. Okay. What is the difference between strong base and weak base? The same thing. Strong base dissociate completely, weak base not really. Okay? pH range, we talk about it. Okay? Why HCl strong acid solution may have pH close to 7?
Super diluted.
It's diluted. Okay? Very, very diluted. Okay, what is the relationship between pH and POH?
pH equals 14 on pH.
Right, pH plus POH is equal to 14, or you can say pH equal to 14 minus POH. That would. All right, let's go to this side. Why NaOH strong base solution may have pH close to 7? It is also diluted. Remember, when your acid and base are diluted, they will be close to 7 because what is presented more in a diluted solution? Water. Right, exactly. All right. What is the difference between calculated POH of sodium hydroxide versus POH of barium hydroxide? What is different when you calculate these two POH? Right, you have to remember that it is 2OH, right? So NaOH will, right, I should say 1 molarity of NaOH will dissociate 1 molarity of OH minus, but 1 molarity of BaOH2 dissociate into 2 molarity of OH minus. You gotta be careful. That means if they have the same concentrations, who do you think is gonna be technically stronger or have more OH? Yeah, BaOH2. It's gonna dissociate more. That means you're gonna have more of the OH minus. Your pH is gonna be really big. Your POH is gonna be small. Make sense? Look at the pictures. Your turn. Tell me which one is a weak acid. First one. Okay, so we said this is a weak acid. Why?
Oh, it shows undissolved, undissociated.
It shows as dissociated, right? You can see, right? Some are dissociated, some are not, right? Still stuck together, right? This one is dissociated completely, okay? Weak acid, okay? This is a weak acid because not all acid are dissociated, okay? So, all right, 2A. If generic weak acid, HA, SHA, write the equation for ionization of HA in water. Yeah, sometimes you will use HA as a generic strong acid or weak acid, depending on the case. Let's try writing it. How would that look like? So let's say HA is a solid. It's gonna dissociate. It's gonna make some H plus, and then it's gonna make some A minus. Okay, aqueous. That's the key. Without the backward arrow, you will not get the grade. Everybody heard it? I do need that reverse arrow. That's the key for that 2A. That's all they want. Okay?
Strong acid is not reversed.
Yeah. Strong acid, don't do that reverse arrow or you will not get point. Got it already?
So they can't turn back to their original.
Okay. Explain why double arrow in opposite direction should be used in part A.
Oh, some of the H and the A will turn back to HA.
Mm-hmm. Some H plus and A minus ions will combine back to form HA since HA is a weak acid, okay? Cannot dissociate completely. All right, equilibrium constant expressions. Okay, we just call them Ka, but it's literally just K. So how do we write K? How do we write K?
H concentration of H plus. Yes.
Yeah. Yes. Okay, product over reactant. Yes, but in this case, we're just writing product. Why didn't we write the reactant? Solid. Okay. Good. Next one. Which of these two substances is a stronger acid? Justify your answer. Take a look at these two. You have HNO2 and then HCl. Who is stronger? Why? Stronger, yeah. Because is Ka value is bigger, which means, what does that mean? What does Ka value mean?
Its ability to disassociate.
Yeah, which means it's associated more. Right, more than HCl. Okay. Alrighty. Okay, I hate these pictures because it's got too close and it's got some cut off. Basically, the top part was just the O and H's. Like this is the O with a two lone pair. This is the O with a two lone pair, and then this is the H. Okay, so that's what is just missing in the picture. So you're gonna tell me which one is the hydrogen that is gonna to be dissociated. Here's an easy question. It's always attached in an organic solution like this. It's always on the COOH. That's the one that is gonna to make into the iron and gonna leak, basically. So in this case, it says so-called the hydrogen. So this is the hydrogen, this hydrogen, and this hydrogen. These three are the hydrogen that is gonna to leave and donate it, right? You will donate these three. Okay, notice that it's OOH, right? Which again, it makes sense that they can leave. Okay. All right. Question All right, let's look at the next one. Next one is nicotinic acid. Okay. It's in the vitamin B3. Okay, written in some structural formula. Okay, let's write the equation for dissociation. So you should still know how to write the dissociation. H6H4NO2. Dissociate. Okay, since we know that it's not strong, what should we do?
Double arrow.
Double arrow. And then make sure you write H plus and then the rest. Okay. Question, what am I missing? Okay. Let's kind of do that. We're assuming it's solid. What else am I missing? -1 because you take out +1, right? So that should be a -1. Yeah, I am missing the charges. That's it. You see these two together? Make back this charge. Charge has to be balanced, right? Weak acid. How do you know it's weak? Because it's not one of the 7 that we memorized this. Okay? All right. Okay, right there at Ka. Okay, this time, let's say this is aqueous. Let's go with the first one is aqueous. I am getting that it's a dilute solution because down here, I read ahead on the CA. Do you see what it's saying? Yeah, so the first part is aqueous, it's diluted. So it's not solid, it's diluted. So we're gonna use it as aqueous. So let's go ahead and do that. So K8, how we're gonna calculate this? Let's write it down. Concentration of H plus. That one, yeah. The minus guy, and then. Yep. Nicotine. Yeah. It's not nicotine. Unfortunately, it sounds similar, but it's not.
Fortunately.
Unfortunately.
I thought the first one was I thought the Oh.
Because of this. It's a solution also, so that's why. I look ahead and then I change it back. Yeah.
Oh, okay.
Okay. All right. Now, that's how usually you're gonna write for the acid anyway. Usually that's what it is. Okay. It could be aqueous. Okay. Now let's go through the next one. We're done. All right. Okay, how do we calculate this? Let's see. You have concentration of acid and you have a pH. Calculate the concentration of H plus in this solution of acid. How do you find H plus? Nope, because remember, this is a weak. Nope, there is an easier way. I don't know if you guys noticed.
Oh, it's just the negative, 10 to the negative whatever.
I give you this. So that means you can find this. Yeah?
You just plug it in.
Because pH is equal to negative log of H plus. That means concentration of H plus is 10 to the negative pH, which is basically 10 to the negative 3.26. Okay? Notice the question. The question seems really large. Yeah, it's not.
This is all
Okay. 5.5 10 to the negative 4. And then, yeah. You forget it, you will not get credit. Okay? What happened? Well, I mean, pretty much logs 10 to the power and your ice table. That's it. I mean, you already did ice table, so. Okay? Make sense? How's this go? Alright, D, let's go do ice tables. Your guys' favorite, I know. Icebox. Again. Okay, icebox. So let's go, guys. Ch16, H4, NO2, go to H plus, and then you have C6, H4, NO2 minus. Okay? How do you do the icebox? Okay, well, take a look. They do give you information. They said the solution was 0.020 molarity, right? Initial. Yeah? Pretty much that's it. Now, notice it's ABC, so that means we can pick up the answer from the previous part. Okay? If you look at it, previous part, I have H plus. I'm going to use it. Notice this H plus number is what? Is it I, C, or E? E is equilibrium number, okay? So 5.5 times 10 to the negative 4 molarity. Okay, we can backtrack it and we can try to calculate what happened. Okay, since we said this is a solution, these we're gonna assume 0. It's gonna dissociate. Minus x plus x plus x. Your eyes is actually really easy. This should just be x, but it's this number, so that means that's this number. Yeah? That means how do we find this? Subtract it, because it's 0.020 minus x. Your x is this. Subtract it. Okay? Make sense? We're gonna get 0.019. About. Really close. But yeah. See that? Concentration of this is this. Concentration of this is this. Concentration of this is this. You guys see that? Huh? That's it. Done. You just have to write it down. Okay, guys. On the test, I know one of you guys did. When I ask you a question and you do the ice table, do not leave it there the way it is. Give me the answer. And then he's like, I know. Give me the answer. Okay, you give me this. Especially, I don't see this at all. And I just see this here without even unit. I can't give you credit. I have no idea what it is. Well, actually, I know, but I still won't give you credit. Okay?
Actually, it makes sense.
Okay. So, I do need you guys to go back and give me the answer. You got to say concentration of H. Hey, AP won't give you credit, so I won't give you credit.
Aren't you different?
Nope. Me and AP exam are the same thing. We'll do the same treatment to you guys, so that you guys know how to do it.
You're like the physical embodiment.
Okay? Well, not really. Hopefully, I will prepare you guys for it. Okay? Well, good. That means you will learn. Okay? I know lately some of you guys, I've been relaxing on you guys, and you guys are slowly starting to forget unit or forget to write answers or do the calculator wrong. Yeah.
Yes, we do the
I
calculator.
swear, it's a one-time thing.
Yeah, one time thing. She go like, Michelle. Alright, okay.
Yeah, unit.
Got it?
I'm crying.
Alright.
Hey, you didn't get some weird number that just magically appeared out of nowhere.
Yeah, well, see, I have no idea what that is.
I guess we all have problems.
Alright, so, no, it's just you guys get a little bit more confidence, which is good, but it's become bad if you guys don't pay enough attention to this stuff.
Got you,
I'm
unit.
so sorry I couldn't have
Right?
You didn't make a number magically operate from nowhere.
Let's go. I know we were staring at your paper for a long time. We're like, what? What Kevin did?
Yeah, I don't know what
Uh,
happened.
We gotta find KA. Right? No. You gotta do this. Guess what? You just figure out all the concentration. Plug it back in here. You have your formula up there. See that?
Yeah.
Yeah. So let's go. So that would be 5.5 times 10 to the negative 4. 5.5 times 10 to the negative 4.
We squared it.
Yeah, you can square it. Okay. Solve for it. I do need the answer. Okay. Careful. I still want the two suffix. Huh? Oh, because it's a number only, so you don't need bracket. If you want to use a bracket, you can.
1.6.
Hmm? Because it's two suffix. It's at 1.6? Okay. Did I have unit for this one?
No, smaller. No.
Okay. Alright. I want you to remember this one. Okay, this is a formula you have to remember.
Oh, what?
Well, actually, it's easy. You know percent ionization. It's basically kind of, right? Like how you calculate your percentage. Okay? So that means ionization. What does that mean? That means you're going to do concentration of ionize this divided by concentration of original
So is it just 1.5
times 100. Divided by what?
0.019.
Yeah. And then times 100. Okay. Now, all these percent questions are end with the multiplier of 100, and then your unit is always in percent. Okay. So what do we get? Oh my God, what did I do? So how much percent dissociation? 2.9%. Yeah, it's really small. It doesn't dissociate at all. Which kind of makes sense if you look at the number. It doesn't dissociate that much. Right? Okay, we got it? Okay. Now you kind of gonna pretty much do this one with guys. So you gotta tell me what it is. Hypochloric acid. HClO. Yeah. Or you can say HOCl. Sometimes people flip things, which is fine. Because the H will attach to the O, and then they like to write H first. So anyway. All right. Write the equation for dissociation. So let's see how we're gonna do it. HClO. First thing first, decide what kind of arrow I'm gonna use. It's a weak acid, double arrow. H is gonna fall out. ClO is gonna be floating around as iron. I'm gonna say they are all aqueous. Yeah, we're not in salt anymore. So, all right. Write the acid dissociation constants for this. So how do we write it? Ka. Same thing, right? How to write Ka? Product over reactant. Yeah, and remember it's concentration. So you just don't want to write H plus. You want to say bracket H plus. Again, I'm telling you guys, I'm pretty sure some of you guys will forget it. So make sure you pay attention to this. Okay? Bracket. If you use a parenthesis, you will not get credit. We already, actually in my AP groups, online, all the teacher, we always talk about it. We're like, when do we not give you guys credit? And then some of them kind of look like bracket, kind of look like parenthesis. You know, I can tell you based on the teacher that we've been talking, it's 50-50. So be careful. Yes, if you're lucky, some teacher might give it to you. If yours is kind of resemble the bracket, but just to make sure, draw a bracket. You know, make sure your bracket is bracket square enough. Okay.
How square is square enough?
You know, it's like kind of like clear angles, kind of.
90-degree, make it 90.
Yeah. Okay. All right. Okay. Or I know that sometimes also people writing in Word, they give you if you also writing in Word.
Like,
No, concentration. So some people might say concentration H plus time concentration ClO minus divided by concentration HClO. That is also known to get credit because they need to know it's a concentration. Okay? Make sense?
there's another 2 seconds, right?
Yeah, you probably spend seconds. So let's go through. See, how do we find that, the guys? They give you Ka. They give you H plus. What do you think? They want H plus. This is the ice tables. Don't start a quadratic formula for this one. We're gonna assumed it.
Assume what?
I'm gonna show you why we can.
Is it supposed to
Because take a look at this. What is it saying Ka was? Pretty small. Yeah. So usually about like -5, then we're gonna start assuming. And also it's because we look at this compared to this. Usually we said if it tend to the -2 difference, about we can safe to assume like about 100 place. So like you know how like this is 10 to the -2 concentration solution. This is 10 to the -8. Yeah, far enough.
Far enough.
Right? So we're gonna do I's again. ICE. Initial is 0.020, right? We don't have these. So we're gonna say minus x plus x plus x. So these two are x. This is gonna be 0.020 minus x. We're gonna plug it in. I'm gonna write it down on this side and down here because I have no room. Okay, so I'm gonna do here. Ka is equal to concentration. I'm not gonna rewrite the concentration. I'm just gonna plug it in, okay, to save room because we already know that x, and then this is gonna be 0.020 minus x. Like I said, I'm gonna assume, okay, because x is small enough. You can say that because Ka is small, really small. Okay, so that means we're saying essentially not many of that is gonna go away. So we're gonna say down here, we're gonna say 0.020, the top is x squared. Let's solve it. So we're gonna get here is, okay, 3.0 times 10 to the -8, x squared, 0.020. So your x is, okay, that's the math. I'm not gonna do that. Okay, so what do we get? Okay, we got an answer? It is really small number. Okay, people who are confused how to do it, you're gonna have that number multiply by this bottom, okay, because you're gonna multiply it, right? That will only give you x squared. To get x, what you're gonna do? Square root. You multiply this with this. We're assuming that it doesn't exist because your Ka, take a look at it, it's very small. In fact, if you solve for that x, you will notice that that x is very small. What do you guys get at that x is? 2.4. Right. Do you see that? Here, I'm gonna show you example. Why you can ignore that x. Because take a look. I am gonna do the math. I'm gonna do the concentration. 0.02, right? So that's the, sorry, can't see. Let me lift it up. Find the area that is, okay, there you go. So you have 0.02, right? What we're gonna do is we're gonna minus by what you just get, which is 2.4 times 10 to the negative 5, right? What do you think you're gonna get? Essentially 0.02. You guys see that? Yeah? It's literally
So it's
close enough. I mean, even if you do two suffix, you're still gonna get 0.02 because it's gonna be 0.0199, so that means 0.020. Essential. Yeah, you can kind of assume it. Yeah, so like what they look for is they kind of look for the difference, and then they're like, yeah, it's not gonna matter much. Okay, so we can assume it. So you have the X. Now you have to go back and figure out. So what is the concentration of H plus? Please do not leave it there. Like I said, your final answer is concentration of X plus, which is equal to X, which means 2.4 times 10 to the negative 5 molarity. See how it goes? Do not leave it as that. And then here's the like, stop picking on me. Alright. pH. I'm just saying I need this answer back.
Michelle, why is it so blue? What have you done to it?
Wait, leave it
Wow.
that way. I like it.
How do you do it? What?
God, William, get somebody.
Okay, small enough because of this.
Gosh, William.
Okay, take a look at this one, 10 to the power. If your 10 to the power is small enough, which is like -8 definitely qualify. Usually by 10 to the -5, you can kind of assume it. I'll tell you guys more about it. There is a percentage that you can calculate that tell you that one is safe to assume. But usually I say -8, yeah, go ahead and assume it. So we just make the math a little bit easier. Now, if you didn't want to, you want to calculate it like the usual. For those of you guys has a quadratic, you can try it, and you will notice that your answer that you get for X is gonna be very close to this. And if you round to two suffix, it's still gonna be that number. So let's save us some step. Okay?
Just assume like, can we apply it to the other?
You can if it's small enough. So you are looking at your K value. If your K value is tiny enough that you can assume it. Usually by about, like I said, 10 to the -5, good enough. Yeah. All right, let's go to the pH. How do we find pH?
Easy. pH is equal to
Negative log.
minus.
Nope, you can't do 14 minus because do you have POH? No. But you have an H plus. That's what you're gonna do. Notice you have multiple equations. It depends on which one you use. You gotta be very, very careful. Okay? Because in this case, like how we were saying, pH is equal to 14 minus POH, which is true. If I have a POH, I don't have a POH, so you have to do pH equal to negative log or H plus. Make sense? You gotta check which one I give you. Okay, negative logs. Okay, also be careful, type negative.
Why is it slowly getting? Okay.
The long shadow of her arm is being cast.
She's losing life points.
His future is not so bright anymore.
Oh my god, you guys. Alright, back to work, guys. Okay. 4.62. Yeah. Okay. Question: did pH has a unit? No. Okay. Your P stuff don't have a unit. Your K stuff don't have a unit. So don't put them. Okay.
Why is everything in temperature K?
Equilibrium.
Everyone
Alright.
has points.
Okay, last one. Before the number 7. Percent ionization, guys. Shh. As a general rule, if the percent ionization is less than 5% of the initial concentration acid, then we can simplify. We can make that simply assumption that allow us to avoid quadratic formula. Okay, so that's what I'm saying. You can kind of figure out what it is. So let's take a look how you do it. Calculate the percent ionization of this. Usually when you finish, yeah, just do the quick calculation percent ionization to see if your assumption is correct. So, no ice. Percent ionization. What's the formula for that one? You just did it on your left side.
Over
Total, the actual.
100.
Okay? So that means
You forgot the time 100.
0.020 is on the bottom, right?
just see it yourself.
On the top,
You have to, but you're still working on 100.
what are you gonna put on the top, guys?
Concentration of H+.
Yeah. Okay, let's go. What do we get? Yep, 0.12%.
What?
Very small.
So that's like negligible.
Exactly. That's why we can ignore that X
Can I
on the
put
bottom.
0%?
No. Alright. 7. Okay, I need you to compare them. You have pH of 0.02 molarity of nicotinic acid and pH of 0.020 molarity of hypochloric acid. Which of these two is the stronger acid? Justify your answer based on pH, not based on Ka value. I want you guys to compare their pH value.
Nicotinic acid.
Hmm?
Nicotinic acid.
Nicotinic acid is the stronger. Why?
It has more H+ ion in solution.
Okay, so we just did it. I don't know if you guys noticed that we just calculate the nicotinic acid, right? See, in 5, in C, well, actually, no, they give it to you. In 5, right, C? So nicotinic acid pH is what? Right, it has 3.26. And the hypochloric acid is in? Right, 4.62. So then, that's what I'm saying. Compare internal this and then explain it. So we're gonna say, who is stronger? Okay. Nicotinic acid is stronger than, okay guys, hypochloric acid. Why? It has a lower pH. It has lower pH, right?
Wait, what? I thought
And
pH didn't have to be
Different definition of strength. There are a lot of different definitions of strength. This one is how much H+ it can dump out.
Oh.
The other one is whether it fully dissociates.
right, so that is why it's thing get really messy when we start talking about which one is a stronger acid.
Context.
Okay, and also yes, like I said, HCl. If I don't give you concentration, you know HCl is a strong acid because it's gonna dissociate completely, right? But what if I said you have 0.1 molarity of HCl versus, I don't know, like 100 molarity of acetic acid? Okay, even though it's 0.1 molarity, right? Even though HCl is a strong acid because it's really diluted, it's not gonna be as strong. It's gonna be close to water, and because acetic acid, even though it's weak, it's really concentrated. Yeah, that's gonna do some damage, right?
That's a lot of damage.
That's a lot of.
So now when we talk about strength, if I don't give you concentration, if I'm not talking about pH, you are just simply talking about those 7 other strong acids. Now if I talk about strength in a sense that I have concentration, I have H+, I have pH or pOH, yeah, now we gotta talk. We gotta compare things now. Make sense? in this case, in a way, it's the same. These both are weak acid. They are weak. But in a case, nicotinic acid is a little bit stronger than this because it can give off more H plus because it has a lower pH. Lower pH just means it has more H plus in a solution. Make sense? Okay. Number 8, blank. The blank, the Ka value is, the stronger the acid is. The bigger, the larger. The larger, the bigger, the higher, whatever you like to write, that all work. Make sense? Okay.
Wait, the K here is like it tells us how much
There you go. All right, 9. Okay, you have two different acids that have the same concentration. Compare their strength with their pH. Explain your answer. How do we compare their strength by looking at their pH? The lower the pH, right, for different acid with the same, oh, sorry, way too far. The same concentration, right? The lower pH, the stronger acid. Now it said explain an answer, so simply saying that is not enough. You gotta explain a little bit. What does that mean to have low pH?
It gives off a lot of H plus.
Yeah. Lower pH means there is a lot of H plus iron in the solution, right? More H plus, the stronger